Sorry to kill so much time with that, but I just wanted everybody to know how terrible I think John Cook is. As a person, as a singer, as a performer, cannot stand them. Okay, anyway, we're back at it. So, here we are. If you struggle with B, let's check it out. We're going to run through the list. Have we played the uncomfortably intense eye contact game in here yet?
Yeah, one time.
Oh, I love the game. It's such a good game. Anybody want to play the uncomfortably intense eye contact game with Old Holloway?
No.
Well, good. Mark, uncomfortably intense. What is the first thing we always check for when factoring polynomials?
GCF.
It is the greatest common factor. That's fantastic. Okay, after we've checked GCF, let's check. Anything that goes into all three of these?
No.
Bummer. King. After we do GCF, what do we always check for? Number, the second step. Oh, that's it. Not yet. We check if it's a binomial. Is this a binomial?
No.
No, so we don't get it. Michaela, if it's not, nope, uncomfortably intense eye contact. If it's not a binomial, what do we check for? Trinomial. Michael, uncomfortably intense. If it's a trinomial, first thing we check for. Oh, my eyes are just so itchy.
Perfect square.
We check for perfect squares. How do I check this to see if it's perfect square? What's the square root of the first term? X. What's the square root of 2? Okay, so it's not a perfect square. 1.414. If you actually say 1 point, nope, don't do it. If it's not a perfect square, don't use it. Okay, so this is not a perfect square trinomial, which means, according to our list, we go to grouping and or it's a shortcut, but we haven't seen the shortcut yet. At least one person in here knows it. So we're going to group it. I'm going to write the number here purely so that we can see it. Is there a number in front of my x squared? What is it? 1. All right, so we're going to multiply a times c right here, and I'm going to write the number 2. That's what the product is. I need factors of 2 that add up to what number, Eli? 3? Almost. You're mostly right. You're colder. -3. You were right with the number, but it has to be the same here. So if you got the wrong pieces, here's where it happened. What are the factors of 2, just in general? We'll just start there. 1 and 2. Easy. Okay, so when we look at this, if I want 1 times 2, it is 2. That works. But if you add these up, what do you get? But what I need is a -3. If I make them both negative, does it still work? Fantastic. If I view this as -2 times -1 instead, is that okay? Yeah, it doesn't matter which way we go. Okay, I'm now going to rewrite this trinomial with 4 terms, and then we're going to put our groupings around them. This is a great place to talk about the most common mistake that I regularly see. I'm trying to mix the colors so we can see it. I'm going to use x squared, and what do I use these magic numbers for? Like, how do I rewrite it with a 4-nomial instead of 3? Minus 1x, and I'm going to switch color here. Minus 1x. And then this is going to feel wonky because the next term is minus 2x, right? I want everybody to include this. Adding a negative is the same as subtracting, and there's a very specific reason that I want you to do this. Here it is, and I'm going to switch back to my blue color there. Okay, on the board right now, we have 2 very different looking things, but if I simplified this and I added these and combined like terms, do I still have minus 3x? So it's still the same thing. Why do I stress this plus sign here? Anybody know? Sonny. So that's what separates it. I'm going to pretend like I didn't do it. I put a group here. Everybody cool with that? And then you're going to be tempted to put a group here. Maybe. If you do this, is it correct? No, because now you're telling me to multiply these things. So somebody's going to say, oh, well, that's okay. I'll just put the group here. Is that correct? No, because you would have had to factor a negative out of this as well to make it become correct when we do it. If you simply add plus the negative in between, we avoid all of that mistake every time. Every single time. Okay, once we've rewritten this and we have our magic numbers, all we have left to do is from our groups, and again, it doesn't matter which way these are written either. Is there something that goes into both of these? What is it? An x. Okay, if I factor an x out of this first group, what does it leave behind? X minus 1. Now this one, I may or may not write the plus. My goal is to factor something out of here to leave behind exactly x minus 1. What could I factor out to leave an x minus 1? If I factor out just a 2, it's going to be a negative x plus 1. But if I factor out a negative 2, and here I'm going to get rid of my plus sign, because now I'm not going to make that mistake. But if I factor out a negative 2, I get x minus 1. Okay, this part, I think everybody's okay with it, but I don't know if we know why. Can you tell me one of the two factors we got, Julia? X minus 1 is one of them, and you were giving me the other one too. X, and sorry, you're quiet and that's loud is really the issue. Did you say minus 2? Okay. Now, this last part always kind of felt like magic to me because we don't really see what's happening. Does anybody else kind of feel the same way, like you're not quite sure why we can do from here to here? I never understood it until like way after Algebra 2 because it just seemed like, oh, well, this happens. Let me explain why this happens. What do you got, Ronaldo? I'm going to tell you, obviously, but does anybody know why we can go from here to here? Okay, don't write this down, but just if it feels like magic, and maybe magic's not the right word, but if you just agree that this is what happens, you don't really know why, I think knowing why might add a little bit of depth to it. Okay, if we were to FOIL, and I don't want you to write this down, but I just want you to see it. Do we all FOIL like this? Is this the first two you do? And that literally says take x times what? X times x and then x times. That's what that first part of FOIL tells me, right? Plus, the next part of FOIL is I'm going to take a negative 1, so I'll just write a negative 1, and it also multiplies by x minus 2. Do we all agree with that? When we FOIL it out and do it, and make sure we see it the same way. Notice, this is almost the exact same expression, they're just rearranged. We have just a way to rewrite FOILing that we don't normally see. It works every time like this. Now, Natalia, I'm going to call on you because I saw something awesome. When I looked at Natalia's work for this one, she didn't have any of this. All that was gone, but she still had the right answer. I don't think Natalia cheated, just for the record. What I want to do is just kind of zoom out and look at the big picture. Pun intended, or play on words intended, I suppose, because I'm literally going to zoom out. When we get grouping up there, and I don't know exactly how I wrote it, but I make a comment about LC. What is LC short for? The leading coefficient. Now, sorry if you have to squint, but looking at A and B, do they both have a leading coefficient of 1? Now, notice, when I get these magic numbers, 1 and 5, if I don't pretend about the grouping, do those magic numbers show up right here again? If it's a 1x squared, I know it's x times x at the beginning, and then all of a sudden, here are those magic numbers that we found. I think we can skip over all the grouping and just use a wonderful shortcut. In this one, my magic numbers are negative 1 and negative 2, right? So if I remember that and I recognize it's a leading coefficient of 1, all I have to be able to do is say x and a negative 1 and an x minus 2 or a negative 2. We can jump through these factorizations crazy fast. We're going to do another shortcut here in a second. We're going to do one more grouping problem with a non-1 leading coefficient. I cannot stress this enough. That shortcut, if you try to use it and it's not a leading coefficient of 1, it will not work. You will be wrong. Guaranteed. Somebody, multiple somebodies will try to do this. You will be wrong. I will count you wrong. When can you use the shortcut? Bet. Good answer, Irva. Cool. All right. Let's knock out this one. And factoring, it seems, I think everybody's feeling okay-ish with it. If you're not, you're doing a good job of flying under the radar. But let's get a bunch of random people to help me out with this problem. All right. I need my list so that I can give surprisingly uncomfortable eye contact with this. Kennedy, anytime we're factoring, always. What's the very first thing that we, nope, right here, eye contact, uncomfortable. What's the very first thing we try? Always. GCF, love it. Okay, when we look at C up here on the board, is there anything that goes into 2 and 5 and 3? No, they're all primes. I don't even have to think about it. Okay, number. This is pure coincidence, I promise. Kennedy, if it's not GCF, what do we do? Number step 2 is my hint. What has 2 terms? What do we call this? I mean, it does have 2 pieces. But what do you call an expression with 2 pieces? Boom. It's a binomial. Is that a binomial? No. Oh, that's a bummer. So just for the record, if it was 6 again.
Jesus.
All right. Just kidding.
Please don't.
All right, Brent. If it's not a binomial, we check for trinomials. First thing we check. Perfect square. What if it's not a perfect square? 'Cause I don't think that one is. Leading coefficient, is it 1?
No.
Huge bummer. So it's 2. We need to group it, right? Like, that's our option. Okay. Don't worry, I can tell everybody's like really bummed out. Everybody in here will get a chance to play the uncomfortable eye contact game with me. Don't worry. Maybe I'll throw a lazy eye in there, like just to get wild. All right. Now, the cool thing is it doesn't change. Exact same thing. Hawaii, if I want to start grouping this, what would you have me do first?
The 5x, right?
So almost. We got to multiply something first.
Yeah, multiply a by c.
Okay, 2 times -3 is a -6. Now, we have to do at least one with a bigger number because every time it's just worked out perfectly. When you get bigger numbers for whatever this product is, there is a systematic way I would suggest you do it. Some of us are better than others at mental math. That's okay. I guarantee some of you are better than me at mental math. When we do this, whenever I list these factors, every single time I'm going to start with 1. If you have to list them all and physically write them down, awesome. If you do it in your head, awesome. But if I have like 30 different pairs of numbers that I need, and there's only one thing that I need them to add up to, maybe if I just jump around randomly, I'm going to miss it. So, help me out with the factors of 6. 1 and 2 and 3. Now, I know that when they add up, they have to be positive, right? So, should the bigger number be positive or the smaller number? If they have to be a positive when we add them, and maybe that was just a weird question, what should be negative, the 1 or the 6? Because it has to add up to a positive, it better be the 1. Now, when we check this, and coincidentally, purely coincidence, this works out perfectly again. Is it the first pair or the second pair? First pair, because -1 times 6 is -6, and -1 plus 6 is 5. Okay, it is this one. We're going to rewrite this trinomial with 4 terms where we're going to replace this 5x using our magic numbers. So, if you get 1 positive, 1 negative, the order never matters, right? Like we've been over that, and I'm going to keep stressing it. But in this situation, I would always do the minus first. Yes, sir? Was it about these numbers?
Yeah. Well, it's because on the other one we made both of them negative.
Because they had to add up to a negative. So every time, remember, I'm checking right here. If I do -1 plus 6, is it a plus 5 that we have right here? That's how we make that decision. On this one, they were both negative because if I made 1 positive, like hypothetically if it had been there, the product would have been -2, which was wrong. And then they would have added up to the wrong thing as well.
How about the 2 and the 3?
What do these add up to if you do -2 plus 3?
But yeah, but what if you made both of them positive?
If we make both of them positive, what is their product?
It's 5.
Nope, that's the sum. What about if we multiply them?
Oh, okay.
It's a positive instead of a negative, right? So we have 2 different things we're trying to balance. Okay, so I'm going to rewrite this, and let's do it to it. -1 and 6. I get a 2x squared, and I would suggest, but it's not really required, if there's 1 positive and 1 negative, I would do the negative first. Minus x plus 3x minus 3. I'm going to group these, and this is the grouping, like this is why it's called this. Group here. Notice if I write the negative first, I don't have to worry about making that mistake in the middle. Okay. Questions before we finish the problem? Where did the 3x come from? Purely out of my imagination, because what should it be? It should be a 6x. Thank you, Naomi. Can anybody tell me why do you think I messed that up? Because I can see the 3 right here, and I was just going quick, and I'm excited because I like factoring. I'm going to make it look like a 6, and I'll change that other one back to red. Thank you so much for saving it. Okay, from here, where to? That's everybody, anybody. What do we take out of this one? I don't understand the hand gesture. Am I wrong? GCF, okay. X? What's it leave behind? Are you sure it's x minus 1? 2x minus 1. Is there anything that I could possibly take out of this to ensure that I leave behind a 2x minus 1? If I take out a 3, I get a 2x minus 1. Do these match? That's the key. This is one of my factors. When we break this guy down, we now have 2x minus 1. And the last one? X plus 3. These are my two factors. Okay. When you did this in Algebra 1 last year or 2 years ago, this was like a whole chapter. Do we need to do more practice here? I want to do one ugly one, and then we're going to really apply this and make them equations rather. But factoring stuff, realistically, 5 says, man, I'm awesome at this. I just needed a reminder. 0 says, what the hell is going on? Anywhere in between. Where would you put yourself? And just to be clear, that what the hell is going on is like, I have no idea what I'm doing, just for the record. 0 to 5. Okay. Question, or you just?
So you know how you had the x and then the 2x minus 1 and the 3?
Yes.
Now, yeah. How do you add to get the last, or do you just?
Are you saying when you say the last? Are you talking from this step to this step?
That step to the
Here to here?
Yeah.
So that's what I was talking about with the FOIL. If we think about what happens with this distribution, like, and I'm going to come here so that everybody can hear it. Because this feels kind of like magic when we see it, and this is what I was trying to hit a minute ago, Sonny, but if you didn't notice it then, now it's fine too. Do you agree that this is what we do with distribution? And that would be a 2x times, and I'm going to rearrange it into a different order just so it looks better. So I'm going to write the x plus 3 on the other side so it looks exactly like we have. Okay, so still the same question though, right? If we distribute, Sonny, this is our first distribution. Do you agree that, like, we could do it, but what I'm really telling you to do is x times 2x minus 1?
Oh, I get it.
Okay, and then this other one is 3 times what?
3 times 2x.
Just 2x?
2x minus 1.
And notice, I can move between these two forms, and we can see it works. All that we're doing is we're using that fact to say, look, I have it exactly like I have it down here. Let's just go one more step and rewrite it like this. And there's a reason we do this, and we're about to see it. Okay. If you need a different explanation, let me know. I'll come talk to you, okay?
Can you have the x plus 3 in front, or does that?
Absolutely. The way it shows up, a times b is the same as b times a. However you write them doesn't matter, but what you write does. All right, last one here, and then we're going to do a little tiny extension, but it makes it pretty chill. That was C, right? All right, last one. I'm going to give you guys a couple minutes. I want you to try this one. We're going to have big numbers. Okay. Okay, that's a... No, I'm good with that one. Okay, it will take a couple minutes. I want you to factor for me 60x squared plus 31x minus 3. And rather than just giving you guys time to do it, because I want to make sure that we can really see the systematic approach, we're going to start it together and I'm going to have you guys finish it. Okay, these are much bigger numbers. And that's okay. Like, there's way more big... I don't know if that's really true. Never mind. Okay, first thing I always do every time is... Who haven't I called on? Cheska, what's the first thing I always do with factoring? I always check GCF. Now, my key to this, 31 is a prime number. Nothing goes into it. I don't think there's going to be a GCF unless it's 31, but it's not 31 because it doesn't go into 3. Okay, no GCF. After that, Perscovia, once we check GCF, what's next?
If we check if it's a binomial, it's not.
This is not a binomial. Love it. Chetty, if it's not a binomial, we check for what? Do you guys know the square root of 60? Not perfect. Okay. Is the leading coefficient 1? No shortcut. Bummer. Which means we have to do what, King? There's no shortcut. We can't do a perfect square trinomial. What's the next step? Louder. Good. Okay. What's 60 times negative 3? Negative 180. Now, somebody in here probably already has the numbers. I don't have them yet. But I need two numbers that multiply to be negative 180, and they add up to what? Can you tell this is a harder problem only because the numbers are bigger? Now, anybody have the numbers right off the top of your head? Because you're probably running through a list in your head if you're trying to do it. When you run through it, whether your list is on paper or just in your head, I want you to do it systematically. It's probably not going to be 1 and 180. I don't think so. Now, You don't have to write them all down every single time, but for a big problem, I literally do write every single one down. 2 times 90, and we'll deal with the negatives here in a second. It's not going to be that one. 3 times 60. Can you guys tell how I'm deciding it's not going to be this? Yeah, there's not a chance. Now, I know that because they have to add up to a positive, these are my negatives. And I can already tell these two add up to 57. We're getting closer, but we're not there. Does 4 go into 180? 4 times 45? 4, so negative 4 and a 45. Do those add up to 31? We're getting closer, though. Does 5 go into 180? 5 times 36? Negative 5 times 36. Do these add up to positive 31? Hey, these are my magic numbers. Now, if you were just trying to think it out in your head, some of you, I'm sure, can find it. Guaranteed. Some of us might be able to do a bunch of them in our head, and then you check one and you skip it because you think it doesn't go in, and now you can't find your numbers. Writing them all out in order can be super helpful. Okay, I'm going to pretend like we didn't, just to save a little bit of space on the board. Negative 5 and 36 are the two magic numbers that we have. I want you guys to finish this problem via grouping. Okay, I'm going to replace 31x with something. What am I going to replace 31x with? Now, everybody probably wrote negative 5x plus 36. Cool. I'm going to be a wild card here. Don't change yours. Do not change yours. Nobody probably did it this way. Is that true? That's a terrible way to ask a question. Did anybody do it this way? No. Okay. Now, it drives me crazy, and I still kind of hold a grudge against Mr. Henningsen. That was my high school math teacher, for not making it clear that it could go either way, because that just never clicked for me. I don't know why. Okay, I've done it very different than you guys. What's something that goes into both of these? 12. Anything else? If I take out a 12x, when I think about this, I'm going to just commit to thinking about it as dividing. If I took 60 divided by 12, it's 5. What about x squared divided by x? X. Plus 36x divided by 12x is just a 3. Everybody cool there? Now, even though I've done it in a separate order, we just have different grouping. Like you have probably 12x minus 1 inside of your parentheses is my guess. But what do I factor out of this to leave behind a 5x plus 3? If I leave or factor out a negative 1 and I get this, we're done. I can see both factors right now. Ronaldo, what's one of my two factors? 12x minus 1. Liam, what is my other factor? 5x plus 3. Okay. I'm hopeful that I am doing this the exact same way that you learned. If not, and you want to show me what you do, I'm happy to try to show different format. But this is how I have factored for the last 50 years of my life. Cool. All right. We are now going to bump it up just a skosh. A little tiny bit. Okay. Everything that we've done up to now has just been under factoring, right? So now the bigger question, why would we ever even need to factor?
I don't know why.
So legitimate question. If you don't know, that's okay. Anybody remember why we factor? All right, cool. You will. And if somebody does and you didn't speak up, you're fine. But always cool with answers. Check it out. Our last little section. Maybe. Last section for today, at least. We're going to be talking about the solutions of quadratics. Now, we haven't done anything yet within all of our factoring stuff that ever had an equal sign. Nothing. We didn't solve an equation. All we were doing was breaking down expressions. The whole point of this, and it doesn't really matter if it's quadratics or not, because we'll see it applies to bigger things, x cubed, x to the fourth, even stuff that looks wildly different. But we're going to start right off the bat. If I think about the graph of a quadratic, does sometimes it cross the x-axis? It could cross twice. Could it cross once? Or touch it once? Could it touch it 0 times? Like, it could be, and you don't need to have this in your notes right now, but just to show you, here's a quadratic that crosses twice. We have 2 x-intercepts. Here's a quadratic that touches it a single time. Pretend like I can draw better. We have 1 x-intercept. What's the no x-intercept look like? Yeah, just shift it up here or down to here. Now, when we look at these, what I see is that x-intercepts are present. Now, when we look at an x-intercept, every time it's when y is equal to what? If we're on the x-axis, what's the y value? 0. Now it turns out that these x-intercepts have a ton of meaning and it varies depending on the problem, but all of this has been in hopes of being able to find those. So when we look at this, couple statements. First thing, we are going to talk about what is known as the zero product property. Okay, you will never see me write this again. I always get some smirks out of this, and that's fine. You will always hear me and see me refer to this as ZPP, the zero product property. All right, it's natural when we think about just what it says, and I'm going to demonstrate that. Imagine two numbers, A and B, and I claim that A times B is 0. Can you tell me anything about A or B? Is it true that one of them must be 0? Could it be both of them? Yes, but at least one of them, right? So the fact that we have if A times B equals 0, then A is 0 or B is 0 is exactly this. If A times B equals 0, then A equals 0, B equals 0, or both do. Okay, where we use this and how this relates to factoring is we just broke this down into the product of its factors. Just like A times B, they just looked a little uglier. When we are solving for our solutions to quadratics, really important. You might see this worded 4 different ways, and I want to make sure we have them all just completely locked in. We have 4 equivalent statements. What does equivalent mean? The same, equal. I'm okay with that. Okay, the first of these, and we're going to hit them over and over and over and over again. The first of these 4 equivalent statements, and they're not in any particular order, just so you know. One way that we can talk about roots and factors and all that good stuff is we can say that right off the bat, x equals a is an x-intercept. And I'm going to be more specific. We'll say an x-intercept of some function f of x. Okay, an x-intercept. That's one statement. The next one, these are all synonyms or equivalent statements. Another way that we could word this is we could simply say that this x equals a is a solution to the equation f of x, whatever it is, when we set it equal to 0. We are making f of x or y equal to 0, which is exactly what we just identified on those graphs. They're the x-intercepts. It's when y is 0. Okay, another way that we can refer to these, we could say that x equals a is a 0 of f of x. And I'll underline, it can be an x-intercept, it can be a solution, it can be a 0. Anybody remember the last one? X equals a is a root of f of x. Now, whether we call them x-intercepts or solutions or zeros or roots, we're doing the exact same thing. Now, honestly, if we're talking graphs, I'm probably going to refer to it as an x-intercept. If I'm talking, or 0, one of those two. If I'm talking about like just an equation without ever imagining the graph, I'll probably refer to it as a solution or once again a 0. Leon.
Why did the second one, x of a, be the solution, have a 0 at the end?
So it's a solution to when we let y equal 0, because we're looking for, like, if I have some graph, what's the y value right here? Yep, and that's what we're doing. Yep, good question. Okay, so let's use one last little example. We're not going to finish the entire section, but that's okay. Example. This time I want to find zeros. Now, this is going to bug you, and you're just going to have to get used to it. Zeros is correctly spelled both with and without this second E. I don't know which one I like more, so literally every time I write it, it'll be different. Cool. All right. We are going to look for the zeros of a function. And let's knock it out. F of x, we'll claim on this one, is now equal to, I don't know, let's get crazy with it. How big of a quadratic do we want? Huge? Okay. So check it out. We have f of x is 15x squared plus 4x minus 3. Now, just language-wise, because there's synonyms, 4 different terms, I'm looking for the zeros. If you look at those 4 equivalent statements that we wrote just a minute ago, that is the same as setting this whole equation equal to what value? 0. And the language makes sense, right? I'm going to put a 0 right there. Would you guys like me, when I replace this with 0, f of x is going to replace with 0. Do you want it on the left or right? So I heard 2. You can do whatever you want. I'm going to do it to the right side because I think that's more natural. 15x squared plus 4x minus 3. And it would be weird if I wrote equals f of x here. It'd be strange. We're going to use a 0 because we're looking for the zeros. Okay. The cool part about this, or the terrible part, I don't really know. It's kind of personal. You don't touch the right side until the very, very end. We won't even bother to think about it. So we're going to factor this. And I need your guys' help to do so. If I run down the list, what's the first thing I always check for? Is there anything that goes into these 3? Is it a binomial? So it's a trinomial. Is the leading coefficient 1? Okay, so I have to group it, right? Okay. What is 15 times negative 3? Negative 45. Now, listing it out, it's not 1 and 45. It's not 3 and 15, although that gets us closer because that adds up to 12 if we do them. Let's see. 5 and 9. Will that work? Oh. 5 and 9. Which one has to be positive? Which one has to be negative? 5 is negative because when we add them up, it has to be a positive 4. Okay. When we rewrite, I'm not going to switch colors anymore. We get 15x squared, but instead of 4x, I lied. What am I going to write? Minus 5 what? X. Anything else? Plus 9x. Minus 3. And it's still all equal to 0. Okay. What comes out of this first group? I don't agree. Okay, my bad. Who haven't I called on today? Joselina, can you see anything that goes into 15x squared and 5x? Any variables? X. Love it. What's it leave behind, everybody? Ooh, not 3x squared because we took out one of them. Just 3x minus 1. Is there any hope of leaving behind a 3x minus 1 in the second one? Lily, what would you factor out?
A 3.
Love it. 3x minus 1. And really important, people get sloppy, and I totally get it, but this is still equal to what? Okay. Can somebody tell me one of the factors? 3x minus 1. Awesome. And the other one? 5x plus 3. Can't forget, still equal to what? Now, on the board, it looks a little different than how we define it. But I'm claiming this thing times this thing is 0. According to ZPP, it means that either this is 0 or this is 0, right? Now, mental math or scratch work, I'm okay with whichever one you go with. I really wish I had a little bit more room. I'm just going to take each factor and set it equal to 0. If I set 3x minus 1 equal to 0, can we solve this for x? I'm going to add 1 and then divide by 3. Now, I'm out of space is the only reason I'm not showing it, but I add 1, divide by 3. Here's one of them. This is my root, my factor, my solution, my x-intercept. What if we set this factor, 5x plus 3, equal to 0? What's the first thing you would do to solve for x? So 5x equals negative 3, and I think I can see the other one now. What is my other x-intercept? Negative 3 over 5. Now, if we just had a graph in front of us, I don't think anybody, even if the graph is drawn nicely, I don't think anybody in here is going to say, oh yeah, that's clearly at x equals 0.3333333. Like, you're just not going to. This will get us there. Now, we will look at this and how it relates to graphing next class, and we'll start to do some inequalities. I do, unfortunately or fortunately, probably unfortunately for you, you get a long weekend, and I don't want you to figure out your math. So here's what I would like you to do. Homework. I want you to do homework 2.3. Very top. I switched it so that the most recent's on top now. Page 81. I want you guys to do 10 through 16. Whoa, that's not right. Is it right? This isn't right. I'm going to change this real quick. Sorry about that. Am I in algebra? I am. Okay. Over the weekend, it is the right page, but I want you guys to do problems 11, 12, 18 through 36 even, 37, and 40. Now, not due until Monday. Last little note, don't do inequalities. There's 1 or 2 inequalities in here. Don't do them. Just hold off on it. We'll do them on Monday. Cool. 18, 20, 22, 24, 26. Only the even numbers. Okay. If you are struggling and you want to check an answer, do 1 odd. I'll post the solutions for you. Cool. All right. Later, Raiders. If anybody decides they want a Cowboys hat, you got it.